Hello and welcome to the fourth video in the SAT math series. In this video we're going to discuss the equation of a line, which is a very commonly tested SAT math concept. Suppose you are going to rent something, and in order to rent something you must pay $2 an hour plus a flat fee of $1. You can formulate the equation of the cost of the rental in terms of the time you're going to rent it through the following equation: y is equal to 2x plus 1. Here, y would represent the total cost, whereas x represents the number of hours that you're going to rent. If we were to tabulate all the values of x and the corresponding values of y, we could get something like this. And we could plot them on a graph. And we could even pick here other numbers, say numbers in between whole hours. But it's already pretty clear that you only needed 2 points because the rest of the points will lie on the same line. And this is what a line is. A line is all of the solutions to this equation. X has a relationship to y given by the equation of our line, and the line is essentially the collection of all the points that satisfy that equation. In school you might have used the point-slope form of a line, or perhaps the standard form of a line, but here we'll be using the slope-intercept form. Let's return to our previous example, where we are renting something for $2 an hour with a $1 flat fee. Suppose you didn't know how much it costs to rent per hour, but you did know that after 4 hours it was $9 to rent, and after 6 hours it was $13 to rent. You could then reason that this difference of 2 hours resulted in a $4 difference, or $2 an hour. And this is the intuition behind the calculation of slope. Slope being the measurement of how one value changes with respect to another. In this case, how much your rental cost changes with respect to hours. And we formulate slope with this equation. M is equal to y2 minus y1 over x2 minus x1. But that is just really asking how much did y change over per change in x. Or, in this case, how much did the cost change per time in hours. And so, a little more formally, what we did is we took two coordinate pairs, that was 4, 9, after 4 hours it was $9, and 6, 13, after 6 hours it was $13, and we basically calculated the slope of this line. So that's the slope. We also have the y-intercept here, and that's going to be pretty intuitive because if you plug in 0 for x, let's take our same equation here and plug in 0 for x. Then this term is going to go to 0, and we're just left with 1. And therefore, an equation in slope-intercept form always has an obvious y-intercept. It's just the number that does not have an x in front of it. And we see that we can quickly go from the equation of a line to a graph using, say, the y-intercept here. If you plug in 0, you get 1. And then the slope helps you draw the line from this point. You need at least one other point to form a line. If you were to plug in 1, 1 would be multiplied by 2, and then added to 1 to get 3. And this is intuitive on what the slope is. The slope, an increase in 1 will increase y by 2. And you can kind of use this to step along a line. An increase of 1 will give you an increase of 2 because here your slope is 2. So a very common SAT question will give you perhaps a slope. Let's say it tells you the slope is 2. We'll do the same line here, but pretend we don't know the equation of the line yet. And it'll give you 1 point on the line. Let's say we had the point 2, 5. And it'll ask you to find the equation of a line. Well, if the equation of a slope-intercept form of a line is y is equal to mx plus b, and we know m, then we know one sample of what x and y can be. We can solve for b since we know all 3 of these other things. For instance, we know the equation of the line will be y is equal to 2x plus b. And we do know that one possible value of x and y is 2, 5, that is y is 5, and x is 2. And so you can see that given a point and the slope, you are able to find the y-intercept here. B is equal to 1. And we would have the equation of our line, y is equal to 2x plus 1. Similarly, they didn't have to give us the slope and a point. They could have given us 2 points. Let's say we got the point 2,5 like we did here. But then we got, say, maybe this point here, which is -1, -1. Here, it's just one step to go from these two to a slope. And then, again, you can solve for b the same way you did here. So, for instance, slope is the difference in y over the difference in x, or more formally, y2 minus y1 over x2 minus x1, which is, we'll do this one as y2. 5 minus -1, that's y2, or I'm sorry, y1, over 2 minus -1. And we see this minus -1 is going to be a plus, and you end up with 6 over 3, or 2. Now you have a slope, and you have 2 points, but just like the previous problem, with a slope and a point, you can get the equation of the line. So you would just proceed here the same way, plugging in either point, and eventually you would solve for your y-intercept, or b, equal to 1. Okay, let's see some SAT problems where these ideas apply. Here we have what is the slope of line t. We need 2 points to calculate a slope. We can use, say, this point here, and this point here. And it's y2 minus y1, be careful with the negative here, over x2 minus x1. We do need some common denominators here in order to perform the subtraction. This is a plus. And this is going to be equal to 13 over 5, divided by 13 over 2. We could divide the top and bottom by 13, and basically these cancel each other. I'm going to multiply the top and bottom by 5, and that will cancel here, and this will be equal to 1 over 5 over 2. And I'll multiply the top and bottom by 2. You could have done any algebra here as long as you didn't make a mistake to get the right answer. And we get 2/5. And that looks about right. If you were to run 5, would you go up 2? Yeah, that looks about right. This problem is rather easy if you know what you're doing, and that reads, which of the following is the graph of the equation? Y is equal to 2x minus 5 in the xy plane. We recognize it's in slope-intercept form, and that this is our slope, and that this is our y-intercept. And as you can see, if you plug in 0, y is equal to -5. We can really quickly find the y-intercept. This one does not cross here, so it can't be A, because we were looking for this point here to exist. This point does exist in B, does not exist in C, and exists in D. Then we could literally try any other point, but more intuition would say we have a positive slope, and we know that this one has a negative slope as y falls as x goes across. So very quickly, D. One more detail is commonly tested, and that is that parallel lines have the same slope and perpendicular lines have reciprocal slope. Here I've plotted 3 lines. The blue line is down here, has a slope of 1/2, and it happens to run parallel to the light blue line. And you can see that they have the same slope here. And in order to be parallel, they're going to have the same slope. In order to have a perpendicular line, the slope must be the negative reciprocal. That is, if our slope is 1 over 2, the reciprocal is 2 over 1, but also negative. And this intuitively makes sense, because if we're going to be perpendicular, that is, have a kind of a 90-degree angle here, and this one will run 2 for every one that it rises, the perpendicular slope will fall 2 for every one that it runs, if that helps you remember it. Let's see some problems where this applies. Let's see that knowledge applied to a SAT problem. This problem reads, which of the following equations represents a line that is parallel to the line with the equation y is equal to -3x plus 4? we know that parallel needs to have the same slope. And in order to find the slopes of these lines, we need them in slope-intercept form. So for instance, for A, if we put y on one side by itself, say by subtracting 6x from both sides, the right-hand side of the equation will look like this. And then we need to divide by 2 both sides in order to get y by itself. And we end up with answer choice A having the proper slope and a different y-intercept, which happens to be a parallel line. All right, let's see a harder problem where we can employ our strategy of working it backwards through the answer choices. Number 26 here reads, in the xy plane, the line determined by the points 2, k and k, 32 passes through the origin. So it's kind of weird since the same constant is found here and here. Which of the following could be the value of k? And it might be unclear how to proceed. We do know that this line must cross the origin. But if we were to just go here and try these answer choices, this would be one way to converge on the solution. For instance, if the answer was 0, that would mean 2, 0, and 0, 32 were both points on the line. 2, 0 here, and 0, 32 would be somewhere way up here. And we can see that that line has no chance of going through the origin. So we could try answer choice B, which would mean that the 2 points are 2, 4 and 4, 32. And 2, 4 would be here. 4, 32, 1, 2, 3, 4. It's hard to say. It's going to be way up here, though. And we could come up with the equation of the line and find the y-intercept, but I can't seem to draw it. But it just seems like it's going to miss by quite a lot. The next answer choice would be 8, which means your points are 2, 8 and 8, 32. And 2, 8 would be here, and 8, 32 would be, it's going to be way up there. But let's actually get the equation of this line and check it. This would mean our slope is 32 minus 8 over 8 minus 2, which is 24 over 6, which is a slope of 4. Then using one of the points, we'll use, say, the first point, we would get y is equal to 4x plus b, and then use the point as 8 is y. The x is going to be 2. And here we're going to get 8 is equal to 8 plus b. And b is then equal to 0. That is, it passes through the origin. So this is answer choice C. I kind of discarded B knowing that that wasn't going to be the answer, but you could have done this with B as well if that wasn't obvious. And we do see that when it's unclear how to proceed, you just can try the answer choices. And again, this is going to be a very useful strategy in turning a hard problem very easy. Maybe easy is a bit much. Let's go with manageable. It lets you converge on the solution. So that was everything we need to know about the equation of a line. In the next video, we're going to talk about translating words to algebra. Also, do feel free to subscribe and like if you would so choose. I'll see you in the next video.